So elliptical function is a function of this nature. F of x is equal to root something. Okay. Now we have four families of these functions. The first one is f of x is equal to root of, so let me put them in this form, a plus root of bx plus c, with b greater than 0. The second family, we have f of x is equal to a plus bx plus c with b less than 0. And the third family is f of x is equal to a minus bx plus c with b greater than 0. The last one is f of x is equal to a minus bx plus c with b less than 0. So from all these families, we're going to use, for now, we just put x there, put negative x here, put negative x positive there, and put negative root of negative x. If they ask us to find the domain of this function on top here, we say x must be greater or equal to 0. If they want the domain of this function, we say negative x should be greater or equal to 0. But after we divide the negative, it becomes x less or equal to 0. Here the domain is x greater or equal to 0. So that here the domain is negative x greater or equal to 0, which turns out to be x less or equal to 0. So these are the domains of these functions. The domain of the function, the domain of the function, and the domain of the function, like that. Now, if we go back to the general one, we'll have the domain as bx plus c greater or equal to 0, giving us x greater or equal to negative c over b. If we come to this one here, we'll have bx plus c greater or equal to 0. This will be bx greater or equal to negative c, divide by b, divide by b. We'll have x less or equal to negative c over b. I've changed the inequality because we have said that b is negative. So whenever you divide by a negative number, the inequality would change. So what would happen if we are here from the general one? We would say bx plus c is greater or equal to 0, giving us x greater or equal to negative c over b. And the last one would have given us bx plus c greater or equal to 0. Also, the inequality would change for us to get this, since we are saying b is less than 0. So using the middle parts, using these functions, we are able to get shapes of each family when graphing. The first family, x greater or equal to 0 in the root, the function will come out like that. The other one will come out like that. And then we'll have another one coming out like that. And the other one coming out like that. So now we name them. So which family? So this is family 1. And family 2 is this one. Family 3 is this one. and family 4 is this one. So let's see if this will make sense in examples. Examples. So you're saying sketch for 1, f of x is equal to root of x plus 1. So you see that b is greater than 0. So we are in family A, family 1. So our first thing is to get x plus 1 equated to 0 and solve for x. So we have x is equal to -1. Quickly get the -1 and take it back in the function to look for a corresponding value of y so that you can have a point. So we'll get the root of 0, which is 0. So we have a starting point, -1, 0. So we can sketch the function. So the function will start from -1. So -1, 0. And the shape goes like that. So our task is just to find what this value is. So how do we find the y-intercept? We go in the function where there is x, we take 0, and they have root of 1, which is 1. So this is 1. The second one, if f of x is negative root of x plus 2, or let's change, let's use a minus inside there, x minus 2. What would we do? The first thing is we would get x minus 2 equated to 0 and get the value of x to be 2. Then quickly take the 2 in the function and get the corresponding value 2 minus 2. This is the negative root of 0, which is 0. So we have a point 2, 0. So now we can sketch at 2, 0, going where? Which family are we in? Where the outside is negative. So we're in this family, family 3. So family 3, the shape goes down. If you were lost and suspected that you are supposed to be in family 2 or family 4, you would always have to get the y value. So you would have said f of 0 is equal to a negative root of 0 minus 2. So you get negative root of -2. This would guide you that this is not the required family. So that's how we get to know again that, oh, I'm lost here.
Now, sir, like I'm a bit more, like I'm a bit behind, like on question 1, on example 1. Like I don't know. I don't know. Like, sorry, I just don't understand how you did it.
What about example 2?
Okay, like I don't know how you're coming up with the square root of 0. I don't know how you are. I didn't start with you. Sorry.
Okay, so let's go back to. So bring it back here. For the first one, we are saying you get what is inside. You get what is inside the root, have it equated to 0, solve for x. So quoting x is equal to -1. The number that you get, this -1, is a value of x. So take this value of x in the function. So you're now looking for f of -1. So at the value you get makes a point with -1. That's what we call the starting point.
Oh, okay, sir. Thank you so much.
Okay. Then now to look for the y-intercept. If you find yourself to the left of the y-axis, and what you have inside the root there, the x is positive, you know that you are going to the right, okay? Meaning you're finding yourself in the families 1 or 3. And both of these families, they go to the right. The graph will be going to the right. Meaning that if you are having your starting point somewhere here, a negative, you will cross the y-axis. So you get the value of x to be 0 and substitute in the function so it can give you the value for the y-intercept. So let's see another example. Example 3, f of x is equal to 1 minus the root of negative 2x plus 4. Our first thing is we get what is in the root, negative 2x plus 4, and equate it to 0. So for x, divide by negative 2, divide by negative 2. So x is equal to positive 2. This value of x that we get here is the one we take in f. So what is f of 2? So f of 2 is 1 minus the root of negative 2 by 2 plus 4. This is 1 minus negative 4 plus 4, which is 1 minus root 0, which is just 1. Now we know that our function is starting at 2, 1. So the graph will start from here. Okay. So which family do we find this? Let's check. Where the inside is negative, where b is negative, and there's also a negative outside. So we are in family 4, meaning that our graph have to come this way. Okay, so it has to come this way. Now, when the graph is coming this way, there are so many things to know. It will cross the x-axis, it also cross the y-axis. So at which point is it crossing the y-axis? At least that point is easy to know. We get the value of x to be 0, substitute in the function, negative 2 by 0 plus 4. That is 1 minus root of 4, which is 1 minus 2, which is negative 1. So it will cross at negative 1, meaning that the graph is going to go this way, crossing at negative 1. So we also need to know the x value. You get the whole function plus 4 and equate it to 0, because f is 0 on the x-axis. So take this number the other side, or let's do what we are used to do. We take one the other side, so we have negative root of negative 2x plus 4 is equal to negative 1. Divide by negative 1, divide by negative 1. So you have root of negative 2x plus 4 is equal to 1. Square, square, you get negative 2x plus 4 is equal to 1. Take 4 the other side, you have negative 2x is equal to 1 minus 4, which is negative 2x is equal to negative 3. Divide by negative 2, divide by negative 2. You get x is equal to 3 over 2. So we have 3 over 2, and the graph is complete. Do we have questions? Do we always have to memorize these families for us to know whether it will go down or up? What other way can we use to get to know? Let's see example 4. F of x is equal to -3 minus the root of -x plus, that is plus 9. So let's see what happens. First thing, we get -x plus 9 equated to 0, meaning the value of -x is -9. Divide by -1, divide by -1. So we have x is equal to +9. This is the value of x. That value of x we take in the original function. So we have -3 minus the root of -9 plus 9. This is -3 minus the root of 0, which is equal to -3 just. So we have a point 9, -3 as a starting point. So 9, -3, starting from there. Okay. Now we don't know where this function is going. So what we do is we'll get the y-intercept if it exists. Okay. F of 0, that is -3 minus root of -0 plus 9, giving us -3 minus root of 9, which is -3 minus 3, which is -6. So we have an intercept at -6. Okay, this means that the graph is coming this way. So that is -6. That means that the graph is coming this way. That is how we get to know, even if we are not memorized the families. Of course, we know this is the fourth family where there's a negative outside and the B also is negative. But then even if we didn't know that they are families, we could as well know that this is going, the only thing that we need to memorize is a shape. The shape will always be of a curve and not a straight line. Does this thing sound doable?
Yeah.
Yes, sir.
Okay.
Yes, it's making sense.
Good. Another one, f of x is equal to 2 plus 3 multiplied by not cube root, but 3 multiplied by the root -x minus 4. Is this 3 going to change a lot of things? Let's see. We always start by getting -x minus 4 equated to 0. So we have -x is equal to 4 divided by -1 divided by -1. So x is equal to -4. This value of x is what we need to take inside there. So f of -4 is giving us 2 plus 3 root of -4 minus 4. So we'll have 2 plus 3, 4 minus 4, that is 2, because that is a 0 there. Root of 0 is 0, so we get 2. So the starting point is -4, 2. So you can be ready to sketch. And run from -4, 2. So there will be a starting point there. Okay, let's see if we have a y-intercept. What is f of 0? F of 0 is 2 plus 3 root of -0 minus 4. This is 2 plus 3 root of -4. So no x-intercept. I mean no y-intercept. No y-intercept. Does it mean we have an x-intercept? 2 plus 3 root -x minus 4 is equal to 0. This is 3 root -x minus 4 is equal to -2. Divide by 3, divide by 3. So we have -x minus 4 is equal to -2 over 3. Get to square things. Let's square that guy. So we'll get -x minus 4 is equal to 4 over 9. So -x is equal to 4 over 9 plus 4. This is 4 plus 36 over 9. So we get 40 over 9, meaning that x is equal to -40 over 9. So we are finding an intercept there. So let's see now. Let's go back. Since we still have the opportunity to go back and check when b is less than 0 and outside is plus, our domain is this x less than or equal to -c over b. So where are we? So we're here, outside is plus. So though it looks as though we are able to obtain the y-intercept, this guy looks like that won't be the case, because if we get this value and take it back in the function, 40 over 9, let's see if it's a true value. We'll get 2 plus 3 outside. The root of 40, -40 over 9 minus 4. That is 2 plus 3, 9 down, -40 minus 36. The guy is negative inside, but it's telling us that it's a root. So we get -76 over 9, which is a lie. So it means that there's no such a value. This means that the graph goes up in this manner. So the 3 was supposed to be seen impacting here if we had an intercept. But the impact of 3 won't be seen directly because we have no intercept. Otherwise, the job of 3 there is to stretch this function, this graph. Instead of it being this flat, it's supposed to be curving up and then going that way. Just a bit showing that the values of x, of y, are increasing faster than the values of x because they're being multiplied by a constant number there, that is 3, as they come out of the root. So meaning that if I had forgotten the families, I have a lot of work to do because I would come this way, have to calculate the x-intercept, getting something that looks like it, but when I substitute back, I get something else again. So there's a confusion there, and not until I get the confusion, I may not know what to sketch. May end up bringing it down when in the actual sense, it doesn't have to go down. Okay.
So does this mean we're supposed to memorize the families?
Yeah, they will be important for us to have an idea of what they are. Very, very important. Okay, maybe another one. F of x is equal to -2 plus, and now let's do the one with the minus there, minus, and the plus inside. Something like that. So get the 3x plus 6 equated to 0, have a 3x is equal to -6, divide by 3, divide by 3, and get x is -2. This number must be taken in f, so we'll have f of -2 is equal to -2 minus 3 minus 2 plus 6, giving us -2 minus -6 plus 6, that is -2. So we have a starting point, -2, -2. So -2, -2, starting from there. Now the family, of course, the family here is known, that is family 3, where the function has to go down. But let's see if it will make sense that it will have a y-intercept, -2 minus 3 by 0 plus 6. That is -2 minus √6. So there's indeed a y-intercept. So this is our family. So that number there is -2 minus √6. Okay, so for now, this is enough for radicals, unless we have questions. The remaining thing now is to solve for these radicals as equations. So when we get back, so we have 6 minutes before it cuts. This is Zoom 40 minutes setup. So when we get back, we'll be doing equations of radicals.
So what time are we getting back?
Immediate. But since there's no exercise yet, we'll have to immediately get back, do equations, Then there'll be an exercise. And then get back to have it revised. So let's log out and come back.